Okay, let's determine whether the following statements are true or false. Okay, the first one is 0 an element of the empty set? Well, the empty set contains no elements, so how can it contain 0? This is false. Is the empty set an element of the set that contains 0? Well, on the right side, this set only contains 0. Nothing else. And thus, empty set is not inside this set because it only has one element and it's 0. So this is false. If you want to make this correct, you say that the empty set is contained or belongs in this set. Now, does a set that contains 0, does that belong in the empty set? Well, this is false because the empty set only contains, well, it contains no element rather. So this has no elements, and this is the set that contains 0. So that's false. Is the empty set, does that belong in a set that contains 0? Well, yeah, that's true. That's exactly what we had over here. Because the empty set is always a subset of any set. So, yeah. So every subset of a set, the empty set belongs in that subset. Okay. Next one, we have the set that contains 0. Does that belong in the set that contains 0? And this is tricky because these are exactly the same. And this is false. Because proper subsets cannot be equal. When you use this symbol, you say that these are proper subsets. What that means is it belongs to, but it does not equal. Okay. We know that these two are equal. They're exactly the same thing. So if you wanted to correct this, you would say you would have to put the equality part on the bottom. So you would say you have to put this equal in order to make this true. But it's not a proper subset because these two are in fact equal. Okay. Now we have the set that contains 0. Now the set that contains the empty set. Does that belong in the empty set? And like we said here, that is in fact true. Because these are exactly equal, so this part is correct. And we say that it's not a proper subset. Okay, now let's focus primarily on the empty set. So is the empty set a set, is it an element of the set that contains the empty set? So this is kind of confusing. This right here only contains the empty set, right? So this empty set is inside here. So in fact, this is true. Is the empty set an element of a set that contains the empty set and the set that contains the empty set? So this is a bit strange, the way it's written. But basically, we can see that in both cases, like if I wrote this separately, if I said this empty set in the set that contains the empty set, and it's the empty set in the set that contains the set of the empty set. This is in fact true. This is the first statement right here. That's true. This one is also true because this right here contains the empty set. So yeah, the empty set will be in here. So this is in fact true. Okay, next one. Does the set that contains the empty set an element of the set that contains the empty set? Well, think of this as like poor notation. We know that these two are equal, so you don't talk about sets like this being elements of other sets like this. Okay, these are actually, they belong in one another, right? Because since these two are equal, we don't say that this is an element of this. We say that they're improper subsets. Or if you want, in order to make this correct, you would say that the set that contains the empty set is an element of the set that contains the empty set. This would make it true. Or this. But this is false. Okay, so yeah, the next question would have been this one. Is the empty set an element of the set of the empty set? And like we said, this is obviously true. Okay. Because if we see here, if we highlight, this is over here. Okay, they're the same thing. So that element is in there. Okay. Now, does the set that contains the empty set belong in the set that contains the empty set and the set that contains the empty set? And in fact, this is true. We know that what this is saying is that this is a proper subset of this. We know in general that this is an element of this, since you can find this in here. And so we can say that it is a proper subset. So this is in fact true. I guess both of these are true. Now the next one is the set of the set that contains the empty set contain or belongs in the set that contains the empty set and the set that contains the empty set. And now this is starting to get confusing because, as we can see here, this is over here. And what I should have said for the previous example is that this is here. I'm sorry, this is in here. Okay. So yeah, this is in fact true. Okay, and last one is a set that contains a set of the empty set. Does that belong in the set that contains the empty set and the set that contains the empty set? So again, this is very confusing. Just note that these two are redundant. They're the same thing. So really, you can just simplify this into one set like this. And so these are exactly the same. Okay. This implies that let's call this A, this call this B. A is a proper subset of B. So the way it's written, that's what it says. But that's false. It's false because they're equal. A equals V. So in order to correct this, you would say you have to put this equality here to make it true. But since they're not equal, you cannot say that they're proper subsets.